Going to do the Norton. So in the Norton, you can convert. So it states that the linear two-terminal circuit can be replaced by an equivalent circuit of a current source and a parallel resistance. So you can convert similar to the previous one. Now you are not converting the part of the circuit to a single voltage and a single resistance. You are converting it to a single current source. Okay. So this time we have a current. Thevenin for voltage and the Norton is for current. So you can see you can convert the left hand side of the circuit to a current source with a parallel resistance. In the previous one you had a series resistance, isn't it? So this resistance we call the RTRRN, Norton resistance, RN. And this is same as the RTH, and you find it in the same way like you found the RTH. Make sense? And this IN is the current when you make this A to be a short circuit path. Do you remember in the Thevenin we made it open circuit between A and B. Now for Norton you need to make it short circuited. Makes sense? Short circuited means you have without a resistance you have a wire there, isn't it? So to find IN and RN, I don't think you have any problem with finding RN because you know how to find RTH. You do the same thing for RN. Are we good? Okay, now let's see how. So IN is the short circuit current. So you making that short circuit. Do you see? We are making a short circuit path. And can you find the current? Now you already know how to find it. So how do we do this for this one? Again, if you use the source transformation, this one can be converted to a current source. Am I right? So that will be 36/12, 3 amps, and you have a parallel resistance which is 12 kilo ohms. Am I right? Milliamps, isn't it? Because they are kilo ohms. Am I right? So this will be, currents will be milliamps, isn't it? 36 divided by 12, 10 to the power 3. So you have a 24 here, am I right? And then you have 2 here, and then you have another current which is 3 milliamps, and you have 10 kilo ohms, and you have a short circuited path. Now what can we do? These two are in what? Parallel to each other, so we can add them. When you add them, 12 times 24 divided by 36, isn't it? 6 times 2 and 6 times 6. 12 times 3 actually, yes. So 24 by 3, 8, am I right? Is that 8 kilo ohms? Okay, so we have 8. So we have 3 milliamps and parallel 8 kilo ohms. And we have 2 kilo ohms and we have 3 milliamps here, and then we have 10. Am I right? Now can we convert this to a voltage source? How do we do that? What should be the voltage? 8 times 3, 24 volts, and your resistor will become series, and it is 8, yes. And you have 8 and 2 and 3 like this. Are we good? Now 8 and 2 are what? They are in series. So when you add them together, what will happen? It will become 10. So you have 24 and 10. 24 and 10 in series. So you can say you have a 24 voltage and a series resistance of 10 kilo ohms, and you have a 3 milliamp current here, and you have a short circuit you have a resistor as well here which is 10 kilo ohms. Up to here, any question? I'll give you time for you to do a question, but do you understand what I am doing? Okay, now these two can be converted to a current source again. If you do that, what will happen? You have a current going upward, 2.4. Am I right? Is that right? And you have 10 kilo ohms like this, and you have a 3 ohms going down, 3 milliamps, and you have 10 kilo ohms and a short circuited path here. Now what can we do with this 3 and 2? 2.4. They can add together, but the direction, if you look at the direction, net current is flowing which direction? Which direction? Upward or downward? Downward. Are we all good with that? So net current is flowing down, which is 0.6 milliamps. And this one is with 10 kilo ohms, and we have a 10 kilo ohms here as well. And our aim is to find this current IN. Am I right? So can't we use the current division rule? 10 and 10. So what should be the IN? This 6 milliamps going like this, isn't it? Am I right? Splitting equally. Why equally? Both the paths, the resistors will be 10 each. Am I right? So IN is 0.3 milliamps. The direction is what? Going upward. So this direction is wrong. So we will get a negative. So this will be 0.3 milliamps negative. Makes sense? Are we good? Is it clear or not? I will let you to do this one by yourself. Okay, I will finish this and we have to move to the other room. Okay, so now
is it supposed to be 0.6?
0 point?
6 milliamps.
Yes, so 6 is divided between, 6 comes to, isn't it? 6 comes to that node and dividing between the two parts. So 0.3 each, but the direction is opposite, negative. So here what you need to remember is when you have a upward current, your circuit should have a downward current like this, opposite, okay? So as you have an upward current, your Norton circuit should be like this. So this will be your A and B. Makes sense? So we found this one is 0.3 milliamps. Going down, why it is going down? I told you when this is upward, it is opposite all the time. Like, this is going upward, so this one is downward. Why is that? This one, the left-hand side of the circuit is giving a current in this direction. So that in your circuit, it is going into the other way around. So that will be downward. Are we good? Did you understand what I was doing? Okay, so this question you can write it down and you can try it and we'll move to the other room. Okay, we have to pack up.
No, bro, only you. So we're gonna have next class, right?
Okay, so find me the Norton current and Norton resistance. So how did you find the resistance? So you switch this off. So 24 kilo ohms and 12 kilo ohms. Then you have 2 here, and then you have 10 kilo ohms here. So that's it. Am I right? So these two are in parallel. So you made it to a single resistance, which is 12 times 24 divided by 12 past 24, which is 8. So this 8 kilo ohms, 2 kilo ohms, and 10 kilo ohms all are in series with each other. So Req is equals to 20 ohms, kilo ohms. So do you all got that, right? Any question? This was done in your Thevenin as well, so you can't have any questions. So what we do, we turn off all the independent sources. So when you turn off a voltage source, that path will become short circuited. So we have a short circuit path here. When you turn off a current source, that path will be open circuited. So to find the Rn, you turn off all the independent sources and you redraw the circuit, which is this. And then you add the resistance. So Req is the open circuit, the equivalent resistance between A and B. So we can see 12 and 24 are in parallel to each other, so you can add them together, and these three are then, all three are in series with each other, so you can find the equivalent resistance, which is 20. So that will be your Rn, which is equals to 20 kilo ohms. Any question? Any question? Okay, now how do you find the current? Current is the short circuit current. So short circuit current from A to B. So you can, you have this circuit now. So you can again, I already explained you. So we found Rn as 0.3 negative. So that means your circuit will be look like this, 0.3 milliamps. We got a current this way, so yes, so we should have opposite direction. I told you it should be opposite. Okay, so we have a resistance of 20 kilo ohms, and that will be your A and B. Am I right? Is this what you got? 0.3 milliamps we got. I explained you how you should get it, and did you get it or not? Do you want me to explain again? Okay, so this, if I convert the voltage source to a current source, what will happen? Yes, current will become 3 milliamps, and the resistance is 12 kilo ohms. Am I right? And rest of the circuit will stay the same. Am I right? Is that right? Now what can you say about this 24 and 12? They are parallel, so when you add them together, what will happen? 8. So you can redraw the circuit again. So you have 8 in parallel to this. Is this right? $10 kilo ohms, sorry, and 2 kilo ohms. Okay, now can we convert this to a voltage source? How can we convert it to a voltage source? Yes, so voltage source and a series resistance. So what is the voltage? 24. Why 24? 3 times 8 is 24. Positive upward. Am I right? Current is upward direction, so the positive side is up. So this is 3 times 8, 24 volts. And we have a series resistance, which is 8 kilo ohms. And we have a 2 kilo ohms as well. And then we have a current, which is going down 3 milliamps, and we have a resistor and like this. Are we good? Any question?
Ma'am, can we start by subtracting the 2 milliamps, the 3 milliamps?
You can't. For the time being, you can't. Why is that? They are not in series yet. Sorry, they are not in parallel yet because of the 2 kilo ohms. You can't do it now. You have to wait till they become parallel. Make sense? Are they in parallel? 3 milliamps upward and downward, are they in parallel or not? They are not. For the time being, they are not, isn't it? Because you have a 2 kilo ohm in between that. So parallel means you have to, these two are parallel, 3 and 8 milliamps and 8 kilo ohms. Those two elements are parallel to each other, but other three is separated by 2 kilo ohms. Do you agree with it or not? I told you at the beginning as well. It's very important the week one. If you don't understand parallel and series, that will be a big problem because we always have parallel and series, isn't it? So we need to do a lot of questions from your tutorial one. Okay, so your homework. They are if they are parallel, yes. Subtract or add depending on the direction. When the current sources are parallel to each other, you can add them together algebraically. When the voltage sources are series together, you can add them together algebraically if they are in series. Are we good? Now what will happen then? So you add 2 and 8 resistors? They are in series, am I right? So this one you can make it to 10. Agree? Now this 10 and 24. So if 10 and 24, you can convert to current source. So when you convert it to a current source, upward current of 24 divided by 10, which is 2.4 milliamps. Am I right? Now your current sources, both the current sources are in parallel to each other. Even the resistor is in parallel with the same. All three are in parallel to each other. You don't have anything in between. So they're all starting from here and ending from here. So they are sharing the nodes, start and the end. Make sense? Now you can add them. You can minus them and there is a net current flowing down which is 0.6. Is that right? Is that right or wrong? So there is a net current flowing down which is 0.6 milliamps. And still you have your resistor which is which was that 10 kilo ohms, right? So 10 kilo ohms and 10. It's like this. So your current, this current is coming to this node and splitting between these two, and the current going here is upward direction 0.3 milliamps. Is that right? So your IN is given as downward, but it is going upward. So your IN is equals to negative 0.3 milliamps. Do you agree with that? Any question? If you don't have any question, I will give you another one for you to try by yourself. When you finish, let me know. Okay, so if you want to convert this to if you want to further simplify this, you can convert this to a voltage source. What will happen? Then you have a like this, am I right? So you have your 10 and a 10 in series like this, isn't it? So what is this voltage? 0.6 times 6 volts. So 6 volt. So if you want to find the current here, isn't it? Am I right? So current is going out from the positive side. So current is equals to voltage, which is 6 divided by the total resistance is 20. So again you get 0.3 milliamps. Again upward because it is going this way, isn't it? So that is giving you the same answer. Am I right? Any other questions? No questions? Can I move to the next question then? Okay, do this by yourself. You need to convert this part of the circuit to a single current and a single resistance. Resistance and the current should be in parallel to each other. So Norton equivalent circuit. Okay, so to find the Rn, what we need to do, we switch off the only source that we have, and 6 and 6 are in series with each other. So that will be 12, and 12 and 4 are in parallel to each other. So 12 times 4 divided by 12 plus 4, and that will be 3 ohms. Okay, so your Rn is 3 ohms. Any question? Sorry, it's yes, it is 3 ohms. Is it 3 ohms? Okay. Who didn't get 3 ohms? 6 and 6 are in series like this, and 4 is like, 6 and 6 are series, isn't it? So you can convert it to a 12, and now the 12 and 4 are in parallel to each other. Because you have this too as well. See, you have the equivalent resistance across the A and B. So you have A and B like this.
Why not combine 6 and 4?
Because they are not either series or parallel. No, 6 and 4 together. Yes. You are talking about this two. Am I right? Yes, they are not either in series or parallel. Why they are not in series? You need to find the resistance. You need to find the resistance, equivalent resistance at A and B now, isn't it? So that means you have it across this one. If you don't have the A and B, if you are finding equivalent resistance somewhere else, for example, if you want to find the equivalent resistance not across A and B, okay? Just say you have to find the equivalent resistance across these 2 points. Then what you do, you need to take this one out. Then all 3 are in series with each other. Because across these 2 points, you can start and go all around here. Am I right? But if you look at the other one, see, if you look at A and B, so you need to find across A and B. So A and B is here. So can you go like, this will go like this, and this will go like this. This path will go like this, and this path will go like this, isn't it? Am I right or wrong? So 6 and 6 are series with each other. So that will be 12. Now the 12 and 4 are in parallel to each other, so that will be 3. Are we good? Any question? Yeah. 4 and 6 are not in series. You need to find the resistance across the A and B, equivalent resistance, isn't it? So if I start from A, this is A and this is B. So if you start from A to come to B, I have 2 paths. I can go like this. Do you agree with that? I can go like this. That is one path. Am I right? There is another path which is going like this. Am I right? So in this path you have 6 and 6 together, and they are in series. They are in the same path, along the same path. But 6 and 4, are they in the same path? No. So 6 and 6 you can add, and they can be, you can say it is equals to 12 because they are in series. Am I right? Again, now look at from A and B. If you say the paths, you can go like this, or else you can go like this. So these paths, even the previous one, you are starting from one point and ending from the same point. Both the green path and the blue path, or else in the previous one, the yellow path and the blue path, both are parallel to each other. You can start and come back to the same point. So they are parallel to each other, isn't it? So when they are parallel to each other, you can add them in the parallel way. So 12 times 4 divided by 12 plus 4, which is 3 ohms. Make sense now? Okay. So any other questions? No other questions? Okay. Now can you find me the IN? Did you find the IN or not? What do you need to do for finding the IN? You can't keep this. Can you keep A and B open? No. What you need to do? You need to make it short circuited. Then you need to find this IN. If you find this IN, your Norton circuit will be, as you have downward direction here, you have IN upward, and also you have this 3 ohms like this. So you can convert it to this, isn't it? Now you need to find this IN. So how do you find the IN? You don't switch off any of these sources. Now one thing, when you have, like, uh, can we first convert this? Can you please convert this to a voltage source? If you convert this to what will happen? 6 times 4, which is 24, plus and minus, it's going like this. Am I right? So 6 and 6 are in series with each other. Do you agree with that? You will have like this, isn't it? So 6 and 6. So that will be 12. So I'm redrawing the circuit with 12. So we have 12 ohms and we have 4 ohms like this. This is what I have. Agree? Any question? Okay, now tell me the current coming out from here and going to this node, and it has 2 paths. Am I right? The current can either flow across the 4, and it can flow without a resistor. Am I right? So which way the current like to go? Resistance is always an obstacle, isn't it? So current, when there is a short circuit, the current would like to go in the easy path. So it's avoiding the resistance. When there are 2 resistors, yes, it is splitting between the 2 resistors depending on the current division rule. But whenever you have a resistance in a parallel with the short circuit path, this resistance current will never follow the harder path. So current is always going in the easier path. So you can get rid of this. You don't need to have this one. Makes sense? So your circuit will look like this. Why? This 4 is no current will going through the 4.
Is there like a math equation for that, or we just like memorizing it, that if there's like a circuit that doesn't have a resistance, we just skip it?
Yes. If there is a path, short circuited path, it is skipping the resistance path, the harder part. It's in naturally it is happening, isn't it? Even you guys, if you have an easier way to do something, you do it the easier way, isn't it? So the current will do the same.
So we just ignore. We don't have like equation for that.
Maybe we can prove it in a theory. I'll check. Okay. For the time being, just remember that when there is an easier path, the current would like to follow the easier path. So current will not go through the 4 ohms. Now can you find the current? What is the current going here? It's 2 amps, isn't it? So downward, so this is upward, it is right. So your IN is 2 amps. Are we good? Any question? No questions? Did you get the 2 or not? So when you draw the circuit, what will happen? How do you draw this part of the circuit? So from next topic, things are getting harder. Okay, so we will be doing after week 5. We are not going to look at this methods. We are going to apply the methods and solve other things. Okay, we are doing capacitors and inductors, first order circuits. So things are getting harder. So it's the good time for you to refresh everything up to week 5. That will help you for your test, and also that will help you for the next topics. So how do you draw this one now? You can draw it like this. So your IN is 2 amps and this resistance is 3 ohms and this is your A and B. So you have converted this to a Norton equivalent circuit. Make sense? Any questions? So we are done for today. If you have any question, we can discuss. Otherwise, we'll wind up the class and I will see you on next day.